Epic, which is a large electronic healthcare record vendor in the United States, already has integrated GPT-4 to do clinical note completion so that doctors can start typing your notes and it can finish it for you. There's several healthcare centers in the United States that are already doing this through Epic. And if I have a note like this, which is a real sentence from a real Boston area hospital that we've collaborated with, and I fill in the first word with a white or Caucasian patient became belligerent and violent, and ask Cybert here to complete this sentence, Cybert completes your clinical note with the patient was sent to the hospital. If I start it with African, African-American, or a Black patient was belligerent or violent, Cybert completes this sentence with the patient was sent to prison. These are really bad associations that are coming through in two different modalities and two very different tasks. This is really hard because bias is present in clinical processes. Why is it present? Because doctors are humans and humans have biases. Nobody is perfect. But the problem here is, if we want to move forward with ethical AI in health, we need to think about where these enter different parts of the pipeline. So today I'm going to talk briefly about some work we've done in different parts of this pipeline. And my goal is to encourage everybody, no matter where you are, no matter what kind of work you're doing, to think about using health as one demonstrative example for progress that you make in machine learning. The use cases are really inspirational, and it also inspires much harder technical challenges, because again, if you do this naively, you're probably going to do something bad. So first, let's think about data collection, which maybe is the first thing you're thinking about given the examples that I just cited. So pop quiz, I hope you had coffee this morning. The coffee here is fantastic. This is a real note from a Boston area hospital. It's a nursing progress note where we've redacted the patient's self-reported race. Can you tell what the patient's self-reported race, not their genetic ancestry, should be here? Should it be Black or white? You probably can't, because we tested doctors on this and they cannot. But machine learning models can. And in this case, maybe you would say, hey, they're using a statistical bias, right? They're using the fact that in the Northeast, where we ran this study, there are more Black patients that have hypertension and they go on dialysis. And we found that you can perform really well at predicting this self-reported race in both hospital settings in New York and Boston, using both simple and more complex models. But some of the things that are being used are not biases we would maybe want a model to be using. So they go past a statistical bias and into what we would think of as a societal bias. For example, if you talk about a skin-based presentation of illness at all, bruising, rashing, anything like that, your patient is much more likely to be white. And that's in part because dermatology textbooks have very few examples of how to diagnose the skin-based presentation of illness in darker skinned patients. Even worse, if you describe a patient or their families as difficult, the patient is probably Black. And these are associations that doctors cannot pick up on, they're themselves doing in notes, but machine learning models can. If we go past clinical notes back into the imaging modality, second pop quiz for the day, maybe you could think about how the subtle ways in which you write about different people would show up eventually in aggregate across millions of notes for a machine learning model. But this is a chest x-ray. How could you extract self-reported race, not genetic ancestry? And self-reported race is extremely heterogeneous with respect to genetic ancestry. So surely there's no biology here that it's using, right? This is a social construct of self-reported race, how you are perceived. What we find is that machine learning models, a variety of machine learning models, in a variety of hospital settings, can detect a patient's self-reported race across a variety of medical imaging modalities. And this is not something radiologists can do. We've also tested them. And if you ask radiologists, what do you think it is? What are the spurious correlations? What are the proxies that the CNN is cheating with here? They'll give you some potential wild examples. Maybe it's using this, 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 this. And we tested all of those. It's not body mass index, it's not breast density, it's not bone density, and it is not disease distribution. In fact, you can, for the EEs among us, you can bandpass filter these images until they do not really look like chest x-rays anymore. No biology there to cheat with, right? And even these images contain frequency spectrum information that allows you to predict a patient's self-reported race with very high performance.
更多演讲实录与文章已收录至雷锋网 ICML 2026深度专区，现已全面上线。专区不仅全面收录了重磅论文的工程化解读、专家前沿演讲，更将持续更新前方记者的第一手会议动态。扫描下方二维码，或进入雷锋网 ICML 专区即可查看。